Okay, recording has started. Thank you. Thank you. Okay, so question number 1 is straightforward. Yes. Is there anybody who does not? I think it is not difficult at all. So can I go to question number 3?
Yes, sir.
Yes.
I think for the benefit of the bottom 10-25% student, let us hold for this for 2 minutes. If somebody wants to copy the solution, he or she can.
Hello, sir.
Yes.
I think, sir, there will be a minus sign in the summation of mx where you put a positive sign. If we are considering only magnitude
Yes,
of
sir.
MC.
Sorry, correct.
Yes, sir.
Yes,
This
sir.
should be minus. This one, no?
Yes, sir.
Final result is fine.
This should be minus.
But
Thank you.
we have to write the 7850 in the answer.
Okay, thank you. Okay. Question, can everybody see this slide?
Yes, sir.
Yes, sir.
Problems like this, I mean, I'm saying it in a very general sense. Don't take my word that this will definitely come. But questions like this are very, very popular in exams. Every year, usually there is a question like this. Not only at IIT Kharagpur, but at other institutes also. Problems like this, where there is a stick which is held by 2 or 3 threads. Questions like this are very, very common. So please make sure that you understand how to solve problems like this. Or later on also, when you will give your GATE exam or other exams, problem like this is extremely common. Okay, what is happening in this problem is AB is a member, A is a ball and socket joint. Ball and socket joint is the 3D equivalent of a pin joint, right? It is like the shoulder. If you look at your shoulder, you can rotate it, you can rotate it in XYZ, but you cannot remove your arm outside of your shoulder. So imagine a joint like that at A. It is held together by threads at B and at D. The mass of the stick, let's say, is 30 kilonewton. Now we want to find out tension at T1, T2, and the net reaction at A. The free body diagram will look something like this, where due to the pin joint, due to the ball and socket joint, I have AX, AY, AZ. I have tension T1, tension T2, and a load of 30 kilonewton is applied. Okay?
Yes, sir. Yes, sir.
Please try to solve this. I want everybody to be able to solve this because, as I said, problems like this are very, very important.
नहीं सर जी 5 मिनट फिर डाउट पाई क्लास में एग्जाम अच्छी डाउट कौन कौन होता है ना अरे कोटी जी बने 10 मिनट रह जाओ है ना
Everybody understands the free body diagram that I have drawn?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
How will you solve problems
Sir,
like
tomorrow's
this?
test.
Yes, yes, tell me.
Sir, what component of T1?
The first step is try to find out the component of T1. Yes, somebody was asking something about tomorrow. Tomorrow there is no test. Test is day after tomorrow.
Test is on Moodle. I mean, day after tomorrow's test is, on Moodle.
Yes.
And is it multiple? I mean, like an objective or a subjective test? Like,
Both are there. So there are some questions where you have to stick. Let us say, is area a vector? Yes or no? And you say, depending on your yes or no, you stick. So
yes.
questions like that are also there. And the questions like the ones you have been solving in your assignment are also there.
So we have to submit the workout, right?
We have to do what?
Like submit the our solution, what we have done.
No, I think the workout, there is no plan of having you submit the workouts in MS Teams.
Okay, sir.
So to, again, coming back to this problem, first is write down.
Sir,
function
test will be on Moodle or
in
MS
Moodle, in Moodle.
Sir, will the tutorials and the lecture notes will be enough for the exam, or we have to study the other books also?
I think they would be enough. I mean, if you look at problem sheet number 3, and if you look at question number 3, for example, or question number 5, or for question number 6, or question number 8, I can tell you none of the questions in the exam is as hard as those questions.
Okay, sir.
Sir, syllabus will be from vector to 3D equilibrium.
Yes, 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 yes.
So can you please reduce the number of questions, because solving
No, but-
14 questions is
But that is the catch, na? If you have more number of questions, keep in mind that the grading is relative, okay? Keep in mind that it is not like your board exam that you must get 90 to get EX. It is nothing like that. As a student, I remember one of these exams, I got 18 out of 90, 1/8. And it was third highest in a class of 90 students or 100 students. So things like that can happen. Don't worry. I mean, it is not that if you don't get 90, you will not get an EX. It is relative grading. But if there are more questions, then what will happen is the tendency to cheat will come down.
Sir, is it relative to our section or to the whole batch of first year?
Normally, it is relative to the whole batch of first year.
Okay.
Where, I
Sir,
mean,
please
roughly, I
give-
can
And
tell
also-
you there are 1,000 students, roughly 950, 960 students. We are looking at 80 to 120 EXs and so on and so forth. So roughly in that ballpark, you can expect, irrespective of how the class performs, because everything is relative.
Okay.
Excuse me, sir.
Question navigable, right? Like,
Yes.
Hello.
questions would be non-navigable.
Non-navigable, yes.
Please, sir, allow it.
Sir, will there be negative marks also?
Some questions
Don't
have
have time.
Achha, one more thing I can
Navigation is-
tell you why
Yes,
non-navigable. I think some of you are saying
Please
that
allow navigation, sir.
if there is
Yes, sir.
navigation, now the sincere boys and girls will get low marks. There will be rampant cheating.
Yes, sir.
If there
is
is
true.
navigation, within 5 minutes, all the questions will be in your WhatsApp group of people who have created WhatsApp group.
Yes, sir, don't allow navigation.
Huh?
The
If you change
values can
order,
be
then it
changed
takes 1
then.
minute to be. Then, if you change the order, then it takes 1 minute for all the questions to be in WhatsApp group. Imagine there are 14 questions and there are 14 students who have made a WhatsApp group, and the questions were assigned randomly. Everybody got a different question number 1. So within 1 minute, all the 14 questions will be in that WhatsApp group.
Yes,
Sir,
sir.
then we can ask,
Exactly.
sir, in EE section, they are asking us to turn on the camera and then give the test. So that way we can do the navigation
Yes,
also.
sir.
Yes.
Does everybody
Yes,
have?
but-
No. I will share you a funny story. I will not name the student.
No,
but
sir, because it's not like the in the middle connection can be there you can be connection go out, so it's not possible simultaneously running to
Yes,
that is right.
So
It
that's
is very
the
difficult. I mean, the
value
bandwidth
of
is also
some
very high.
Excuse me,
We
sir.
use mobile phones as calculators. So if you
Let's
don't
not
use
tell a
mobile phone,
story,
how
I'm
can you
interested in
calculate?
that.
correct. No. Let me
Yes,
tell
sir.
you one story. So listen to my story. It is somewhat interesting. Okay, so we were doing this summer quarter. You know what is the summer quarter exam? Summer quarter exam is the exam which you take. Let us say you fail in this subject, then you get another chance to pass this subject by appearing in this subject in the summer. So we were conducting this summer quarter exam of some subject, not mechanics, some other subject. And there were 12 students who are giving the summer quarter. So I thought 12 students are there. I told them all of them should on their video camera, and then it goes on like that. After some time, what do we see? That one boy is writing the exam, I can see it, but in the background, his father is actually changing the cloth. So it is not necessary that all of you have a room. Yes, all of you have a personal room where you can study and nobody will disturb you. It is not necessary.
Yes, sir, I don't have.
Yes, sir.
And it is also possible
Yes,
that
sir.
your mother, your
Yes, sir,
father,
I
your
also
sister
don't
are
have.
doing something in the background. If we make you to on the
Yes, sir.
camera, we are breaching your privacy. In mechanics, that will never happen.
Sir, but in other courses,
Excuse me, sir.
there is
Yes,
mandatory
sir.
to
In
turn
the
on this
electrical
camera.
also
Due to
students
New
Sir,
Year, there
only
is very
electricity,
loud
not
music going on in my locality from last 2 days, and it will continue till New Year. I could not study.
Or
So in
I think
IIT Bombay, it is compulsory.
problems like this, I think you have to talk to your faculty advisor. I mean, it is outside my power to do anything about it actually. But okay, let us go back to this is my solution of question number 3. If you have done it, please check. If you have not done it, please copy. This is very important. Make sure you understand what is going on.
Sir, can you 1 second show the FBD of the diagram?
So in this solution, x component is basically moment about the x-axis and y component is about the y-axis.
Yes. So basically, MA is equal to 0, X component is equated to 0, Y component is equated to 0. This is the free body diagram.
Yes, sir, done.
I think it is better that I should share my screen, then I can go from one app to the other, right? This is the solution. You can see the solution, na?
Yes, sir.
Yes,
So
sir.
what I've done is
Yes,
I've
sir.
taken moment about point A, equating X component to 0, equating the Y component to 0. I get the value of T2, T1, summation Fx is 0. Reaction at A is Ax I cap plus Ay J cap plus Az K cap. Equate it to 0 one by one, you will get the solution. Ax, Ay, Az, and then A is square root of Ax square plus Ay square plus Az square.
Sir,
Yes.
if we calculate moment about AC 0 is equal to 0, that will directly give us T2.
Take moment
Yes,
about.
sir. I have also done in that way.
Okay, that is also fine. That is also
Yes,
moment
sir,
about
I
which
was.
point?
Yes,
Moment
sir.
about which point?
AC, sir. AC
About
line.
point, no, sir. About axis AC.
That is also
About
fine. That is also fine. That is also a correct way of doing it.
But for T1, we have to again write about point A.
Yes. I mean, at the end of the day,
No,
if
we
only T2 was
for
needed,
that,
then what you're doing is right.
sir, for T1 we can take the axis AD. Oh, sorry, AD is not good.
How have you written the X component and Y component in a single go? Means that
I
would
have
take.
written all the forces in I, J, and K component, and then I have done it like that.
Oh, yes, sir.
With some
Means that
practice,
there would be some
with
more
some
steps.
practice, it will come, don't worry.
Excuse me, sir. Sir,
Yes.
suddenly, when you equated T1I with equals to T2, we have to also write the A component of A.
But I'm taking moment about A, na? So AX, AY, AZ are passing through that point.
Sir, could you just show me the first page of the solution just?
Yes. Is the solution visible?
Yes, sir.
Yes, sir.
Excuse me, sir.
Sir?
Yes, yes.
Sir, I'm getting a little different values. I mean, instead of 45.8, I'm getting 45.76.
Maybe you are right.
Yes,
I
sir,
am,
me too.
I am assuming-
45.759.
Yes, sir,
Like this.
45.759.
Yes, sir.
maybe that, yeah,
Look at
could
that.
be. Could be. I have just taken it. I have rounded it off to one place of decimal.
Okay,
Sir?
sir.
Yes. Yes.
Point A is ball and socket joint. That's why there is no moment about point A.
Yeah, but AX, AY, AZ is there.
Yeah, yeah. Thank you, sir.
That is coming in. Huh? Okay. Now can I go to the next problem? Is this clear? Everybody knows how to do now. I mean, the important step while solving
Yes.
problems like this is to represent vector T1 in vector format. If you are able to do that, I think most of you will get this problem right. The
Yes, sir.
error can come only in writing T1 in vector format. That is the key.
Yes, sir.
Can you tell once more which forces you took into consideration? I mean, which force equations?
So you want me to write it here? No, it
No,
is there.
sir. You can just dictate it.
It is written here. T1 is T1 magnitude of T1 into this. Getting this number is difficult, or is the key. If you get this number right, then more or less different approaches, but you will get this problem correct. Unit vector into the direction of T1, that is the most important step while solving problems like this.
So taking moment about A will do the work, or we have to make another equation?
Moment about A will give you T2 and T1. Summation of all forces is 0 in vector format gives me AX, AY, AZ.
Sir, is there any another method besides this vector approach?
Yes, there are
Because
in
this is
mechanics.
not
There are so many methods. Like for example, calculate the moment about axis AC. Then you will directly get T2.
No, sir, I was
Yes,
asking about sir vector approach के अलावा से कोई
वेक्टर अप्रोच के अलावा भी कर सकते हैं, बट उसके लिए विजुअलाइजेशन आपका बहुत सॉलिड होना पड़ेगा. आई मीन you should understand the figure. It is possible, but for that you need visualization. This vector approach is foolproof. Even if you don't understand the figure, if you are able to read the numbers carefully, vector approach is the safest approach.
Okay.
Sir, in question 4, we have to answer yes or no.
Yes, yes. So that is my next question for you. Question number 4. How many of you could solve it without using your calculator?
Sir, vector approach is the easiest way.
So depends person to person. I will not go which is better, which is not better. I think if somebody is very good in visualizing, he'll prefer that. But problem sheet number 3.
Okay.
We have to. Yeah, different people have different strengths, different weaknesses. So problem number. Yeah. So I was talking about problem number 4. Problem number 4. How many of you could solve this problem without using a calculator?
Yes, sir. Me.
This is actually a very, very simple problem. Let me share the screen. This is worth discussing actually. Abhay, you have some question. You have some question, or you want to make a point?
No, sir. No, sir.
Okay, you have raised your hand. Okay. So this figure is visible.
Yes, sir.
Okay.
Yes,
Now
sir.
let us look at this way. So maybe 1 minute.
Sir, the answer to this question is no.
No.
Answer is no. Yes.
Answer is no. Okay. Yes. Thank you.
Yes, sir.
Yeah, so it is something like this. Okay. Now, how can we solve this without using calculator? That is that is something that I want to discuss. This is a very interesting question, I think. So let us look at it. Let us look at this figure from the YZ plane. Okay. So in the YZ, you will see a stick like this. You will have this tension T is somewhere here. And you have a force here. Okay. These two forces, this mass and this tension, is on the same plane. It is on the XYZ plane. So what will be the resultant of these two forces? What can you say about the resultant? So let us start with the assumption that it is in equilibrium. Okay, let us assume that
In Z it will be non-zero.
So it has to also lie in the YZ plane, yes or no?
Yes,
because
sir. Yes, sir.
if two forces are
Yes,
in
sir.
one plane, the third force also has to be in one plane. We don't know the magnitude, but it has to be something, it has to be like this. Yes?
Yes, sir.
Now if you look at my body, it is subjected to three forces. Yes?
Yes, sir.
This force that I have drawn is the resultant of the two threads. Okay, so let's call this TR. TR is the resultant of these two threads, and TC is the tension of the thread at C. Now TR, TC and MG, they have to be in the same plane. TC and MG are in the same plane. So TR also has to be in the same plane. If it is not in the same plane, then it cannot be in equilibrium. So let us assume that it is in the same plane. Now TR, TC and MG have to be what for equilibrium?
Concurrent.
Concurrent. Now you
Wow.
know the
Concurrent.
geometry. You know the geometry also. So this is
That will
1.2.
not be possible.
This is 1.2. This is 0.8. This is 0.8. This is 0.12. If you extrapolate these three lines, they will not converge. Therefore, the forces are not concurrent. This is not in a state of equilibrium. No need for any calculations.
Sir, can you again explain it?
Sir, my
Yes, sir. Can you please again explain?
Yes.
Yes,
I
sir.
can. So in this one,
Yes, sir.
you look at this figure carefully. TC and MG are on the YZ plane. Agree or disagree?
Agreed.
Yes, sir.
Tension TC, MG are on the same plane. Now, if my body is in a state of equilibrium, then the resultant of the two threads at TA should also be on that same plane. Otherwise, my force will not be in a zero. I will never get summation Fx is zero. Yes? So,
Yes, sir.
the resultant of the two threads, which is starting from A, should be also in YZ. So I am drawing the free body diagram of this stick as the one that I have drawn. There is a stick TC, there is a stick tension TC, MG, TR. Now, these three forces should be concurrent. Otherwise, it will not be in a state of equilibrium. But the problem is this length is 0.8, this length is 1.2, which is the same as this. This is 0.18, this is so. Control P. So I am saying that this is 0.18, this is 0.12. Similarly, this is 0.12, this is 0.18. Okay, but this is 2, this is not equal to 1.2. So the three forces, the three vectors
Sir, your
are not,
voice is not clear.
so these three lines are not going to be concurrent.
No, it is clear only.
Okay, yes, I got it.
Got it? No,
Excuse
there
me,
is no
sir.
need for any calculation. Just by visual inspection, you can say that
Yes,
the
sir.
answer is
Yes, sir, got it.
Excuse me, sir.
yes.
TC
Sir,
is in
now what will
voice.
happen after we leave it like this? Like where it will move.
What's happening?
Yes, somebody had a question.
Sir, now
Sir,
what will happen after we like in which direction would it move? What would be the dynamics I was asking?
toward the wall.
I don't know. I have to solve it. I will
Sir,
not
in
be.
this question, these three forces will never be concurrent.
Yeah, that's why it will never be in equilibrium. That is the answer.
Sir, in this extrapolation method, we have to be very precise with our measurement, now.
Extrapolation means?
Sir, to find whether these forces are concurrent or not.
Sir, you can simply see it, sir. By the geometry, it's visible clearly. So we
Yes.
can do it. We can do it by only simply mathematics.
If you are able to do it with mathematics, it is not wrong. I am just showing you an example of how this problem could be solved without using a calculator. By using a calculator, of course, you can solve it. That will not be wrong. That is also right.
Sir, tension at C
Sir,
is
sir, actually, I did not understand the direction of the tension at C, sir. Can you explain?
Wait, before that, somebody was asking tension at something else. Same question.
At C, sir.
Tension at C.
Yes, it is shown bent towards x axis. So there will be component in x axis.
It is.
Sir, it is.
It is in the x-axis. Y is equal to 1.2. Z is equal to 0. This point.
Sir, I have solved it by taking moment at A. It can never.
But you found it now that it is not in equilibrium, correct?
No, sir. By intuition, the moment has three component.
Huh.
About C, sorry, two component, and about G, it has only one component in one direction.
Yes. Correct. That is also okay. Yeah, that is also a good way of solving it. It says, let us take moment about point A. Okay, if you take moment about point A, mg will only have one component. Tc will have two components. So individually, both the components cannot equate to 0. So the body will not be in a state of equilibrium.
Sir, no. Moment of TC will also be in one direction only. And that direction will be same as that of weight.
Yes,
Sir,
sir.
then why?
Because one component will pass through A. The line of action of one
Sir,
of the
we
components
can
will
also
pass
sir.
take
through.
the
Through
moment
Z
about
axis.
point
Yes.
A and C.
They are right. So the student who proposed this answer is not right. You are right. The others are correct. Yes.
Sir,
Sir,
1.2 is in
sir,
which
TC
direction?
is in the
in
plane
X?
of YZ.
TC is in YZ. Yes. The Y value is 1.2.
So,
X is 0.
sir,
Okay.
so
And
if the
what is the
question
direction of
had
TR, sir?
What is?
The direction of TR.
TR direction V is.
It's in the same plane, YZ plane, because the
It has to be in the YZ
equation
plane because otherwise my
symmetry.
one force is not. It is this one. It has to be in the YZ plane. Otherwise, two forces are in YZ plane. The third force is not in YZ plane. Summation Fx cannot be 0.
Sir, I have a sir. So if the question had the string at equal distance from G, then it would have been in equilibrium, right?
It might or might not have been in equilibrium. Then you'd have to do something else. Yeah, it could have been. Yes, then it can be in equilibrium. You're right. Yes.
Sir, if we take the moment about A and the point of suspension of the wire at C, then only the weight is acting. So the moment cannot be zero, so it cannot be in equilibrium.
Correct. That is also another way. Yes. So there are multiple ways. My point is, it is not necessary always to jump to a calculator. By looking, also sometimes you should be able to solve.
Sir, TC is in XY plane.
TC is in YZ plane. This is Y, this is Z. X is in this direction. This is your x-axis.
Sir, here you said these three forces are not concurrent.
That's why they are not in equilibrium. Yes. This is the x-axis.
But these three forces are in one plane, that is YZ.
But three forces in one plane need not be in concurrent.
For that,
Sir.
these three forces should be concurrent.
Three forces should be concurrent for equilibrium, but it is not happening, so it is not in equilibrium.
So TC and T are making same angle with the Z axis.
Because the geometry is same, na? 0.8, 0.8, 1.2, 1.2.
Yes, sir. Yes, sir.
Okay, clear? Can I go to question number 5?
Yes, sir.
Yes, sir.
Yes, sir.
Question number 5. This is actually a door where this C is resting on a wall, D is free. D is not connected to the wall. Okay? And it has friction at A and B. So this door is actually resting on its three edges, at A, at B, at C.
So actually this question is very hard to visualize, sir.
Problems which are
Sir,
hard to visualize will be easy to solve only by vectors.
Excuse me, sir.
But first, let me try to help you visualize this, okay? And then I will get to your question. So,
Okay, sir.
let us imagine a coordinate axis system such that X, Y, Z is the coordinate axis system on which your door is acting. Door is at X, Y, Z. Okay? The wall is at X prime, Y prime, Z. This angle is 35 degrees. So the door is at an angle 35 degrees with respect to the wall. In this figure, X, Y, Z is the coordinate axis system which is corresponding to my door. X prime, Y prime, Z prime are the ones which is corresponding to the to the wall. So it will look like something like this. Even if you are unable to visualize, you know that at C, there is a point contact. The wall is bigger than the door, so I have a reaction which is perpendicular to the wall.
Sir, we can also solve by the
Y prime I am saying is perpendicular to the wall, so I have a component Cy prime. Or if you are looking at the coordinate axis system with respect to the door, you have Cx, Cy. At A and B, they have said that it is friction. Okay, so I have Ax, Ay, Az, Bx, By, Bz. This angle is 15 degree, this angle is 35 degree. This is how you can visualize.
Sir, may I ask a question?
Yes.
Sir, the inclination of the door with the wall is 35 degree from the base.
Yes. And
Sir, I am having facing difficulty visualizing the angle that is made by the top, because given that one end is free and the other end is bounded at point C, right?
Yes.
Oh, sir, sorry, I didn't notice the 15 degree. Sorry, sir.
This would be a very
Excuse me, sir.
easy problem to discuss if I was in the class. We could take a book and rest it with a wall. We could easily see. Unfortunately, I don't have that tool with me, but I think with the free body diagram that I have drawn, it should be clearer, yes or no?
Excuse me,
Sir,
sir.
I tried solving this for the normal reaction at T, sir, but I am not getting that. I am getting 1339 into mg.
That is fine. That is fine.
Sir, the answer of NC is not matching, sir.
Yes, sir.
There is some
1339
error
it
in
is.
the answer.
Okay, but we'll get that later. I want to make sure everybody understands now geometrically how the door is resting.
Yes, sir.
Excuse me, sir.
Yes,
sir, the normal at C shouldn't be perpendicular to the door.
No, it should be perpendicular to the
To
wall.
the wall.
Because the wall is bigger
Sir,
than the
every
door. We had discussed.
Sir, every time when
Wait. we had discussed this during our 2D equilibrium, that if the wall is bigger than the ladder, the force is perpendicular to the wall. Remember, we had that video.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
Sir, I
And
always
another
used to visualize on a circular surface. That's why I never got cleared.
Come again?
Sir?
Yes.
Sir, in the constants given in the book, it always assumes a circular surface. That's why I got confused.
Sir, point A, B, and D is in D. Point D is free.
D is free. D is free. A and B are friction. C is resting on a wall. I think the value of Cn is wrong. Yes, it should be 0.134. I think this is your question, is it?
Yes, sir.
Yes, sir. Yes,
This
sir.
number wrong. I also think this number is wrong. So
Friction is acting opposite.
Sir, we
Z
can
and
also
A.
figure that out from the answer of BZ and AZ.
I'm getting 0.134. So is the visualization clear? If the visualization is clear, please try to solve this.
Excuse me, sir.
This is
Sir?
my answer actually. Please have a look. If you have solved it, very good. If you have not solved it, please look, study. If you have any doubt with my solution, you can ask me.
Excuse me,
Yes,
sir.
sir. This is the coming.
Sir, 15 degree is the angle between AD and vertical.
15 degree is the angle between AD and vertical. Yes.
Okay, sir.
Sir, please show your FBD once more.
Visible?
Sir,
Yes.
why have you assumed CX?
Why have I assumed?
CX. There can be free movement about CD.
Why have I? D is free. D is not joined to the wall. D is a free edge.
I'm talking about C.
Your voice is not clear. Which one?
Sir, 15 degrees angle, the angle between D and Z, sir.
15 degree is the angle between AD and
The vertical axis, Z axis.
and
Sir,
vertical axis.
sir, I was talking about point C. Why
At
have you
point-
assumed CX?
No, Cx, there is Cy, depends on the coordinate axis system. There is Cx and Cy. If you are looking at the coordinate axis system, which is parallel to your door, there is only Cy prime if your coordinate axis system corresponds to the wall. I have shown both just so that it is clear.
Sir, I didn't get it.
I am saying that there are two coordinate axis systems which are possible. One is x, y, z, where x and y are parallel and perpendicular to the door, where x is AB. Basically, using AB as x-axis, I can have a coordinate axis system x, y, z. I can have another coordinate axis system which is parallel to the wall. So x prime is parallel to the green wall.
Okay.
Cy prime, if I look at my coordinate axis system, x prime, y prime and z, then I have only reaction Cy prime. But if I go to coordinate axis system x, y, z, then it is Cx, Cy. Both are same. I am just showing both so that it is clear. I am not saying both of them exist simultaneously.
Couldn't we just normally consider CX?
It depends. At the end of the day, you want a single value. What is Cn?
So we can assume only CY dash.
Yes. And define and write clearly that x, y, z are coordinate axis system defined with respect to the wall. That's why there is only Cy prime. Cy prime, I've written the perpendicular to wall.
Which coordinate system should we follow then?
Up to you. I mean, at the end of the day, we are just looking for the final answer. Both are right. As I said, in mechanics, there is no one right or wrong way. You could get the answer by
Sir,
any of
So in A and B, it is joined at A and B. That is why we are considering AZ also and BZ also. I thought they were just
normal. Ax by is coming because the floor is rough. It can want to move in any direction.
Sir,
Okay, okay.
CX is along door or on the green wall?
I think
It should
Let
be
us-
along the door.
let us focus our attention on this part of the free body diagram. I think many people are having. Okay, let us only focus on this. For the time being, you can forget about other parts. Okay, let us look at this. So I am saying that there are two coordinate axis system definitions which are possible. X can be parallel to AB, okay, or X could be parallel to this wall. Now, if I have my coordinate axis system X parallel to AB, then the reactions at C are Cx and Cy. However, if my X axis is parallel to the base of this wall, it is, let's say this is my X axis, this line. Okay. So let me make this bigger and brighter. So I can also have another coordinate axis system such that this is X. This red line is my X. Okay. And of course, perpendicular to this will be Y. This is Z and this is Y. So now, if I have this coordinate axis system which is drawn in the red line, if I choose this coordinate axis system, then the reaction at C is Cy prime. If I have my coordinate axis system as shown by this dotted line X, Y, Z, then my reactions are Cx and Cy. Both will not happen together. Depending on the choice of coordinate axis system, you will have only one of the two. I'm
So
showing both
CX
of
is
them.
along the door and CY is perpendicular to the
Correct. Yes, because X, Y, Z coordinate axis system is defined such that AB is parallel to X.
Sir, at point A and point B, there is a socket joint.
Yes.
Point A and point B.
Is different of CX and CY.
No, let one at a time. So somebody was asking about B and B, there is a socket joint. No, at A and B, it is rough. So you are getting AZ and BZ is the reactions due to the weight. AX, AY, BX, BY is due to friction.
Okay, sir.
Okay, yes. Some other question, anybody?
Can you show your solution?
Yes, I can. Is this
Sir,
free body diagram clear? Now everybody is able to visualize.
CY dash is the resultant of CX and
Yes, sir, it's clear.
Excuse me, sir.
Somebody was asking resultant of Cx, Cy is Cy prime. That is correct. Yes.
Okay, sir.
Yes. Somebody else also had some question?
Sir, now what
Sir, see-
about which axis we should write moment equations?
Sir, can you show your
I mean,
solution?
at the end of the day, we are only looking at the final answers. Both will be right. One might be easier, one might be longer, slightly linear, but both will give you the right answer as long as you are consistent. This is my solution.
So CY is perpendicular to the wall. CY prime. CY prime.
Cy prime is perpendicular to the wall. Yes.
Okay, sir. Okay.
So is the solution visible?
Yes, sir.
Sir, can you explain the moments that, I mean, the second two moments that you have written? I mean,
Which one? MBZ, MBY?
yes, sir.
So what I have done is I have taken moment about point B along the Z axis. Moment about point B along the Y axis. Then I will get the different values. So if I take moment about point B about the Z axis, the reactions at B also AZ will pass through, will give me 0. So I get directly AY. If I take moment about point B along Y axis, I'm getting AZ, so on and so forth.
Sir, in that first equation, you have multiplied Cy with H cos 15. Sir, I'm getting sin 15 over there.
No, it's right. It's right. It will be H cos 15. You have to take the height, na? There. When the perpendicular
Achha,
distance
yes,
from the base.
Yes, sir. Yes, sir. Okay.
Achha, we are given the width, na? I didn't see that. So that's why I was not able to write.
number given in the problem sheet is this number 0.1636. Yes, what is it? 1.6. So this is actually comes out to be right. Depends on which component you are looking. 0.134 is Cy, but Cy prime is 0.1636 mg. Some of you have stopped at this, but this was requested in the answer. Cy prime, not Cy.
Okay, sir. Yes. Okay.
Sir,
Yes.
if we write the moment equation about AB, about the AB axis, then we will get mg, only mg and Cy cos moments about that axis.
That's what I have done. Summation
So,
mx means about axis x is equal to 0. AB is passing through x axis.
So moment of mg will be mgh sine 15.
No, mg h by 2 sine 15. It is passing through the
Oh,
centroid.
h by 2, yes, h by 2 and Cy h cos 15.
Yes, that's what I've written, no?
Okay, I forgot h by 2, that's why.
So how did you find CX?
I got confused.
How did I find what?
CX?
Cx by this equation at the top. By the knowledge that the coordinate axis system x, y, z and x prime, y prime, z prime are at an angle 35 degrees to each other, which was described in the problem.
Sir?
Yes.
Sir, in moment about BZ, there will be a weight moment. So there will be 3 terms now.
Yes, sir. I was also thinking that.
Mg passes through the z axis, no? Mg is parallel to the z axis.
Moment of mg is 0.
Okay, sir.
Sir, can we do by writing coordinates of each point?
I think so. It should be possible. It might just be that it is slightly longer, but it should be possible. What you are saying is not fundamentally wrong.
Yeah, it's possible. I did it that way.
Sir, please
Sir, I
show the
have
solution once again.
Please what? Somebody is saying, please what?
Sir, please show the solution once again.
Achha, tell me one thing. How many of you are attending this class from a mobile phone? Roughly?
Sir, I am me.
Sir, I am attending.
Me, sir. I am
Me,
attending.
sir.
I am attending.
Mobile, then
Me,
I
sir.
cannot. Then it's okay. I was about to write in smaller handwriting, then I thought maybe some of you are mobile. But in the mobile phone also, whatever I have written is visible, na, clearly.
Yes, sir. It's
Yes,
visible.
sir. It's
Yes, sir.
visible.
Yes, sir. Comfortable.
Yes, I don't use the PC because the first day I used the PC, the bandwidth was high and nothing was coming clearly. So that's why.
Achha. Okay.
Sir, can you scroll down a bit, sir?
Sir,
Yes, sir. Yes,
in
thank you.
moment about MBZ, why MG is not taken?
Because mg is parallel to the z-axis.
Even if it is parallel, it is not exactly passing through. We
But
can take
dot product will lead
R
to
will.
zero. Dot product will lead to 0, I think.
Okay.
Yes, sir. Done, sir.
Good. Then we can look at problem number 7. Okay. In this one, I think the only problem historically, whenever we try to solve this problem, the only problem is implicitly we are assuming that ay is equal to 0. Ay plus by is 0, and that is you cannot find the value of ay and by. Other than that, I think this is a simple problem. What I have done here is I am looking at this. This is the yz. This is the zx plane. Zx X plane, the figure looks like this. Z, Y, the figure looks like this. And we want to find out P, AZ, BZ. There is no way to find out AY, BY. You can say that all the forces are parallel to the Z axis. So maybe you can start with an assumption that AY and BY are 0. But it is not clearly mentioned. Either you assume that AY plus BY is equal to 0 or AY and BY individually are 0. And then you can solve the problem.
Sir, I have one more doubt.
Sir,
Sir, the doubt is that this is similar to a bearing, yes? The joints at A and B. So why there is not a moment?
Bearings
Yes,
allow
sir,
rotation.
moments.
Bearing allows
Because
rotation.
in notes we were told that whenever this is similar, that it allows free translation along the axis of the bearing.
Yes, sir.
Apart from that, all the motions are constrained. So why we have assumed no moments equation?
No,
So
I think
moment
bearings
along
allow,
y.
ball bearings allow rotation. That's why the wheel in your cycle is rotating. It has a ball bearing inside. Yes.
Sir, but that is only in one axis, no sir.
Yes,
In
sir.
other two
Obviously,
axes it is constrained.
Movement along
Yes,
Y
sir.
and
Right. Understood. Understood what you're trying to say. And then the width of the ball bearing is not given. So are we assuming it to be negligible? I mean to say, this width is not given. Yes. This width is not given, or is it given? The bearing at B is represented by a point which is 100 millimeter away. So if the
Not
bearing
given.
at B is a point, then it is allowing rotation also.
I did not understand, sir, what you are trying to say.
I'm trying to say
Sir, I
sir,
also
even if you do not consider it as bearing, then we can also see that the moment is constrained.
no, my
Rotation is
point is
constrained.
this dimension. Can you see this length that I'm drawing here by these two parallel lines? The distance
Yes.
between two parallel lines, if this is finite, if it is some number, then what you are saying is right. There will be moments. If it is not finite, it is infinitely small, then there will be no moments. According to the
Sense.
dimensions that are given in the problem, this bearing at A is actually represented by a point. Distance between this axis and bearing at A is a point. It is 100 millimeters. It is not that it is 100 when it starts, 110 where it ends. If this
Understood,
length
sir.
was finite, then what you are saying is right. If it is infinitely small, then it doesn't cause reactions.
Sir, even if we consider a very small size of bearing, the rotation is constrained here.
The rotation is constrained, so that's why you are getting AZ, BZ. You will get moment in that way. If you only look at one constant at a time, then the moment is not constrained.
Please, sir, go again.
I'm saying that the moment is constant because you have put two supports at A and B.
Yes.
If there was only one constraint, then there would be no constraining of the rotation. While drawing a diagram, we'll draw it individually. Now, because there is a constraint, A, Z and B, Z can cause a moment.
Yes.
Yes, so even if it is constraining, AZ and BZ can cause a moment. That is accounted for in our free body diagram. When you draw free body diagram, only look at one constraint at a time. Do not look at the others.
Sir, about AB axis, it cannot rotate still.
About? Yes, about. That's why you have AZ and BZ, which is the net reaction moment, if it is possible. Because you cannot rotate. So essentially, you are saying this cannot happen. It cannot rotate like this. Yes.
Sir, but translation movement, we used to take different restraint, and for rotational movement, additional movement restraint.
Only look at one constant at a time. Nah? If you look at only one constant at a time, it is allowing to rotate.
One means?
Imagine like this. Do you have a finger ring?
No, sir.
Imagine you have seen a finger ring.
Yes, sir.
Now imagine that you put a pencil inside your finger ring.
Okay.
can you rotate the pencil in the 3 axis? Assume that the radius of the pencil is smaller than that of the ring. Then can you rotate the pencil along the 3 axes?
Oh, yes.
Now, if you put the same pencil inside 2 rings,
Okay.
now can it rotate?
Somewhat not.
That's what the same thing is happening here.
Yes, sir. Then we will draw the movement in a free body diagram.
When you draw free body diagram, you should only look at one constant at a time. The reactions at B is independent of whether A exists or does not exist.
Okay.
That's what I'm saying.
Okay.
A and B together are not causing rotation. So the
Okay,
reaction
got it.
of A and B together will lead to a moment. That's why you have AZ and BZ.
Okay, understood, sir.
Sir, the reaction in E must be in just that direction. Like in other direction also, there would be some reaction.
Yeah, but that's what I was saying. That is the assumption we are making, that all the applied forces are in the Z direction. B is
It's
in
not
the Z
like
direction.
we have to.
Sir, why we are assuming AY and BY and 0?
Complete, please. So you are right. We don't know the value of AY and BY, but we know AY plus BY is 0. We will stop there.
Yes, sir, we know it.
Huh?
Sir, that's why we are assuming, or other reason is there for it.
No, that's why we are assuming. I think it is otherwise a statically indeterminate problem. You will not be able to solve it.
Sir, because all forces are in the Z direction, then you are considering that along Y direction force is 0.
Then I can only say AY plus BY is 0. I cannot say AY and BY individually are 0. That I cannot say,
sir,
but I
that
can
is-
say AY plus BY is
Resultant
0.
force along the Y direction is
Sir,
0.
we have only assumed that, or there is something or else.
I think we are assuming that this question otherwise is statically indeterminate. Okay, now please try to solve this.
Sir, if we take the moment about z-axis and then equate the force equation along the y-axis, then we can prove that they are both 0.
Come again. You want to do what?
That AY and BY are 0.
Sir, can you share your screen again?
Yes, sir.
Yes, I can. Yes. So what should I do?
So moment about z-axis we can take, then AY will be equals to BY, and the force equation will be AY plus BY is 0. So they are both 0. We can prove that.
I'm taking moment about z-axis. Yes, this is 100, correct. By symmetry also I can say it is 0.
Yes, sir.
Yes, you are right. Thank you.
No, sir, we cannot do like that because the tension in the rod will also produce a moment in that direction along with AO.
But they are parallel to the z-axis. Tension is parallel to the z-axis. P is parallel to the z-axis.
In the moment about z-axis, it is possible.
Z-axis.
Yes.
That the rod can rotate about AB. That's why there is no moment about x-axis.
It's a bearing, so it can rotate about which axis? The x-axis, yes.
And along y-axis, we are just assuming AY and BY, AY plus BY is equal to 0.
We are not assuming. We can prove that AY and BY both are equal to 0. Like take moment about z-axis, then you'll find that AY is equal to BY. Because the distance from the origin to OA and OB are same. So take moment about z-axis, AY is equal to BY, AY plus BY is equal to 0. So AY and BY both equal to 0.
Yes, sir. Got it, sir.
Okay, so please try to solve this. This is very straightforward. Once you understand the front and side view, then I think this is not very difficult. Is my solution visible?
Yes, sir. So the previous slide.
ठीक है, try. Dhanesh, do you have a question?
Sir,
Yes.
that if we only have one ball bearing, then we do not have movement.
I am unable to hear you. The line was not clear. Can you repeat?
Your voice is breaking.
Sir, am I audible?
It is not clear.
Hello.
Yes, yes.
Sir, I was saying that if we have only one ball bearing, then there is no movement about the axis.
If we had only one movement, then it could rotate about all three axes.
So no movement will be there.
No, what is there?
No movement.
I did not understand.
Sir, if there is only one bearing, no movement.
Can you type your point?
Aman, just type in chat box.
Sir, there is someone has not muted. That's why it is echoing from his speaker only.
Okay, so let me once. Okay, I'm muting everybody. Then you unmute yourself and speak. Now, please unmute yourself and ask the question.
Sir, if there is only one ball bearing, then the then the rod can rotate about all three axes.
Yes, one ball bearing of infinitesimally small width.
And there will be no movement about any axis.
Yes, there will be no moment reaction.
Because of here two ball bearings, that's why Z moment is coming.
Correct.
Thank you.
And I think the solution would look something like this.
Sir, can you scroll it up?
Scroll it down. But it is just this much. The whole solution is in one screen.
Sir, could you just once show the FPD? Okay, done, sir.
Done now. Let us wait, I think, for 2 to 5 minutes. Those who have not done, please copy it. And then you try to do it yourself later on.
Done right now.
In this online class, I am most worried about the bottom 25% students who are not speaking out. Maybe they are understanding, maybe they are not understanding. So I am writing the solution at least actually for the benefit of those people.
Yes, sir.
We can take screenshot for reference.
So it's better to write. Your screenshot, you will not remember. If you write, you are likely to remember.
Yes.
In fact, don't only copy it. This is for checking only. If you're absolutely unable to do it, then okay. But this, at least use this to check the answer that you have got.
Sir, can you discuss question 6?
Question 6.
Yes, sir.
Question 6.
Yes, 6 and 8.
I have not understood the question, sir.
1 minute. We will do question number 9 first. Let us do our odd number question that I have targeted, and then we'll look at 6. I will talk about 6 later. Wait, I know what your problem is. So, okay, question number 7. Everybody understood this free body diagram?
Yes, sir.
Yes, sir.
And this solution?
Yes, sir.
Yes, sir.
Yes, sir.
Can we go to question 9?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay, so question number 9 is there is a bent rod which is hinged to a vertical wall by means of two brackets. These are the two brackets. Now, upper bracket fits in a groove so that it will not slide down. So, upper bracket is constraining both X, Y, and Z movement translation. The lower bracket is only translating Y and Z. It can still move down. Okay. Now, what I have done here is I have drawn the free body diagram, which is partial. Partial in the sense that I did not draw the reactions at the two brackets. And my hint is this much is enough to solve the problem. How will we solve this problem?
Torque about
Moment about
zero.
AB.
About AB.
Correct. So to
I
take
can't
moment
see the
about
slide.
yes.
Sir, I can't see the slide. Will I leave and rejoin?
Everybody else can see the slide?
Yes, sir.
Yes, sir.
Yes, sir.
You can leave and rejoin.
Yes,
Try.
sir.
I am sharing my screen.
Excuse me, sir.
Yes.
Sir, won't there be two components of force at C?
No, it is
No,
perpendicular
because
to
it's
the wall.
frictionless.
Frictionless, it is this CZ is perpendicular to the wall. XYZ is defined in terms of the wall. If
Okay,
you
okay.
define a coordinate axis system in terms of line BC, then you will get two components. But
Sir,
here,
in case of any object supported against a wall, the normal force will be perpendicular to the wall, always.
if the wall is bigger than the support, I
Yes,
mean,
sir.
It is also
Bigger in what
frictionless.
sense?
huh? Wait, let me
Bigger in
explain.
what sense?
Let me explain. So, imagine that this is the floor. Imagine that this is the wall. Okay. Now, imagine that I have an object. Let's put it in orange color. Now, if it is like this, the wall is taller than the object. So the point of contact is in the middle of the wall. Then it is perpendicular to the wall. Okay.
Okay,
On
sir.
the other hand, if it was something like this, then it is perpendicular to the orange box. The one which is the golden rule is the one which is taller will define the normal reaction is perpendicular to that. In
Okay,
this
sir.
case, the reaction is perpendicular to the orange box. In this case, it is normal to the wall.
Thank you, sir.
Sir, can you say what does a bracket constraint?
Yes, sir. I have not understood the bracket constraint.
I have also
Okay, let me 1 minute. Let me Google a bracket image. Then we can discuss that. Bracket in a wall. एक मिनट हाँ. Snip. Can you see an image that I have copied?
No, sir. Yes, sir, you can see now.
Sir, yes, sir.
This wooden plank, imagine it's holding AB. Okay. To join it to the wall, sometimes you have a clip like this. Can you see this black clip?
Yes, sir. Yes, sir.
Sir, your audio is not clear.
So this brown object, let us say this is AB. Okay. Can you see
Yes,
this
sir.
black clip? Can you see this black clip here?
Yes, sir.
Yes, sir.
Yes, sir.
This clip is holding my cardboard with whatever this object is. It is holding it, right? So this is example of a bracket.
So it's like a pin.
It is like
Nail.
a pin. Yes, you can. In older times, remember we used to have this electricity lines which would be outside the wall. It would not be concealed.
Yes, sir.
Yes,
In
sir.
that,
Yes, sir.
it would be inside a pipe, and that
Yes, sir.
pipe
Yes, sir.
would be tied by
Yes,
a
sir.
U-shaped.
Yes, sir.
That is a bracket again. That is another example of a bracket.
Yes, sir. It's mean the. Yes, sir.
Sir,
Along
once
the.
again,
So basically, it fixes something to the wall.
Correct. Yeah. Something like this. Look, this is how a TV bracket is.
Okay. So the movement won't be
It then
constrained
allows
and
motion in one direction.
translation.
So in this, moment is constant in two directions. This bracket at B will allow this to slide up and down along the axis, but not allow it to move in the two perpendicular directions.
Yes, sir.
And here it is written that the upper bracket is in a groove. The upper bracket is in a groove to prevent the rod from sliding down. So if I want to draw the free body diagram, there are 3 reactions at A, 2 reactions at B.
Sir,
What does
means
groove
cavity,
imply?
in
can't
the
understand.
Yes?
Sir, where
What
that
does
there
groove
would be
imply?
groove.
Groove is something that means that even one more constraint is stopped. So
How,
a
sir?
bracket with a groove will look like this. So only a bracket will look like this. So this is a ring. So this is a bracket. Imagine if I make a cross section, this is a bracket and the rod is going inside it.
Okay.
This is my rod, let us say, okay?
Yes, sir.
This is my rod, this is my bracket. So I'm making a cut somewhere here, and if I look at it from the side, it will look like this.
Yes.
So now the rod cannot move in these two directions, which is, it cannot move in this direction. It cannot move in this direction.
Yes.
But it can move in this direction. It is only a bracket, it can move in this direction, the one shown in dotted line. Yes or no?
Sir, at groove there will be two
Yes, sir.
forces.
Now, wait, let me complete this point. So this is a normal bracket. A normal bracket is stopping rotation in this two solid lines direction. It is allowing movement in this dotted line direction. Now, to stop this, usually what we will do is we will put a groove. What does a groove look like? The groove is something like this. So now I will put something like this here also. So bracket with a groove is shaped like this. Now inside this, if I put the circular thing,
Sir, groove means what?
so this
Okay, got
rectangle, that can you see?
Yes, sir, got it.
Yes,
This is a
sir, we
groove.
got it.
This is a groove. Now if I put this rod, some sort of hole slot is made here so that the groove can be fitting. Wait, this should be sent to back. Okay, so now my rod, actually I'm making a slot and putting this groove inside. Can you see?
Yes, sir.
Now the
Yes,
motion
sir.
is also constrained in this direction.
Sir, along with force, an extra movement will be added.
No, again, it is infinitely small. So the it allows to rotate, but it does not allow to move in any one of the three directions if a groove has been added.
Okay. So in both
Sir?
the
Let him complete in both
the brackets, there will be two movement and the bracket with group three forces, and both brackets two movements each.
No. In the bottom groove, there is two perpendicular reactions. In the top groove, which has a bracket, it has three normal reactions. Grooves allow rotation.
It will not rotate in two directions, no, sir.
It will rotate
Perpendicular
in
directions.
It cannot move in two directions.
Okay.
Again, a bracket is like
Sir,
putting a pencil inside your ring.
Okay.
It is a very similar
Got
thing.
it. So here,
Sir,
if the groove was not very small, we would have taken a restrictional movement.
Yes, but it is going to be infinitely small, so you can neglect.
Sir, it is not
Sir.
mentioned in the question anywhere, so how can we know that
Yes, sir.
it is?
By default, if it is not given, it means it is infinitesimally small. If it is bracket of finite width written, if it's only written bracket or it's only written groove, then it is infinitely small.
Sir,
Sir,
in the
movement
question
of
it is
AB
not
is
given
like
bracket, that
So
is,
let
it is
him
very
complete.
small.
Let one at a time. The moment in something you were asking me, yes, complete.
Sir, the arrangement of AB is like the previous question, na? Two rings with a pencil.
Yes. But two rings with a pencil, and in one of the ring, we are also putting a perpendicular slot so that it cannot move. That is the groove.
In that upper groove, there will be only movement about AB.
About the three axis is not possible. Movement, translation is not possible. Rotation is possible.
But in the previous one, about one axis, the rotation is not possible.
No. It was not possible if you have two rings. If you only look at one at a time, all three rotations are possible.
Yes, sir. But here also we can see two rings.
So in this also, if I only look at the lower groove, lower bracket, then two translations are restricted. If I look at the upper bracket, three translations are restricted. Individually, they are not restricting any rotation.
Sir,
Why
not
Sir, if in the question it is not given,
Sir, I
it
don't
is not
get it.
said about any.
Yes.
Yes, sir. It is not said about the group. Then it is very small.
Yes.
Sir, in this question, I'm getting 45 Newton instead of 45 kilonewton.
Yes, sir.
Yes, it should be 45 Newton. I am also getting 45 Newton.
Okay, thank
So once this is clear, look at this free body diagram. Try to find out the unit vector along length BM. Then I think you will be able to solve this. I think that is the only difficult part.
Sir,
in case
Sir,
if it is infinitesimally small, why are we restricting rotation? Why are we not considering rotation?
Because if it is infinitely small, it allows to rotate. I mean, okay.
Not in all directions it is possible.
Sir, can you explain the forces at the grooves?
Let us try. First, let us try to answer this rotation question, okay? Imagine that this is a ring, okay? From the side view, it looks like this. This is the front view of a ring. This is the side view. Okay. Now, we have put a pencil. Something like this. So let this be in yellow color. Now I have.
So your audio is very low.
I'm not speaking actually. I'm just drawing it. Okay. So this is a ring. Inside this, I have put a yellow pencil. This is what we'll look at it from the, if you look from the length of the pencil, this is how it will look from the side view. Correct? Yes or no? Now,
Yes,
if this ring
Yes, sir.
is, if this ring is infinitely small in width, is this allowed?
Yes, sir.
Yeah, so rotation is allowed. That's what I'm saying. However, if my ring was thick,
Say once again.
if the
Can you
ring was
explain
thick,
once again?
yes. So basically, imagine that.
Sir, your voice is.
Imagine that. Okay. So bring to 1 minute. Let's bring this to front. Oh no! Wait. Bring to front. So imagine that you had a very thin ring which is blue in color. From the side, and you put a pencil inside that. From the side, it will, and the pencil is yellow in color. From the side, it will look like this. And from the, if you look at it from the tip of the pencil, it will look something like this. Okay. Now, if my ring is infinitely thin, then is this allowed? Can I rotate it like
yes,
this?
sir.
Yes, sir.
Yes. If my ring is very thick, is this allowed?
No, sir.
No, sir.
That's what.
No, sir.
If it is infinitesimally small, then rotation is allowed. Otherwise, rotation is not allowed. This
Sir,
is a
what
practice.
happens if we add another ring here?
If you add another ring,
Yes, sir.
then individually one ring is not allowing the rotation, but both of them together, one of them individually they are allowing rotation, but both of them together are not allowing rotation. But when we draw the free body diagram, we will not care about this ring. We just have one ring and the pencil, draw the free body diagram. Then I only have the second ring and not the first ring, and then I draw the free body diagram.
So
But now you are saying that the rotation is not allowed. The rotation is not allowed, but due to the two rings, I am going to get some reaction, let's say AZ and BZ. On the system as a whole, AZ and BZ can cause some moment. Both of them together are not are constraining all rotations. Cumulatively, the reactions to both of them together is also leading to a moment. So it satisfies that way. Understood? I mean,
Yes, sir.
let us draw the free body diagram. So my point is, when I'm drawing the free body diagram, I will only look at one ring. And one ring is allowing rotation, is not allowing movement in this direction. So I put one. Similarly, the other one is also putting. Let this be AZ. Let this be BZ. Now, AZ and BZ need not be equal. I mean, it is subjected to other loads also, let us say. So, AZ and BZ are not equal. If AZ and BZ are not equal, there is a moment, yes or no, due to AZ and BZ. There is a couple.
Yes, sir. Yes, sir.
Yes, sir.
So, this couple is happening because both the rings together are not allowing some rotation. One at a time, they are allowing rotation. So, the reactions are AZ, BZ. But if you are looking at both of them together, then the reactions AZ and BZ have a reaction couple. That couple is coming because rotation is not allowed. Understood?
Yes, sir.
Sir,
Yes,
here
sir.
only these
So
two
while
forces will
drawing
come.
the free body diagram,
No,
we
no.
have to consider only one ring at a time.
Yes. Whenever you are drawing free body diagram, not irrespective of whatever constraint you have, only look at the constraint, understand what the translations and what rotations are allowed, what are not allowed, draw the reactions for that constraint, and individually go one constraint at a time. There are only very rare cases where you will look at both the constraints together.
Okay, sir.
Sir, only these two forces will come in the FBD.
No, it is part of a much larger system. I'm just drawing the reactions.
There will be no moment.
There could be applied forces, but yeah, this FBD is correct. Yes. This FBD
Sir,
for
what
the
rare cases?
so the complete FBD will be this.
Really small dot or rotate
You are also
one
going to get a
direction.
normal reaction. I mean, perpendicular, right?
Sir, what rare cases we are telling that we have to look at both constants?
I think Professor Sushanto Chakravarti must have talked about it. That
He
there
was
were-
talking about links.
there are some specific cases where you look
Yes,
at.
sir. Yes.
Otherwise, in general, this approach will help you. That only look at one constant at a time and then draw the free body diagram subject to that constant and take it forward from there. Do not worry about what the other constants are.
Sir,
Okay.
there will be no moment about any of the group.
No, because it is allowing rotation. So Tanmay has shown a bracket. So if you look at, so this is a bracket for a flat plate. We are not looking, this is not a, can you see this photo that Tanmay has sent?
Sir, is that a bracket or clamp?
That is actually a bracket for a flat plate. See, this glass is flat. It is not a bracket for a ring or a rod. So this, in the context of mechanics, this is not a bracket, this is a clamp.
Okay.
Because this glass sheet is flat, it is not a ring. In our problem, it is a ring. We are trying to hold a rod. We are not trying to hold a flat plate. Okay, so coming back to our problem now, find out the unit vector along NBM. So NBM you have to find out, and then summation MBM is equal to 0. Moment about axis BM is 0 should help you solve this problem.
Sir?
Is my solution visible?
Sir?
Yes.
Can you please explain question 8?
First, let us finish this. Na? There is time. We have still
Sir?
20 minutes, so we will do this.
Yes, sir.
Sir, will you
Sir,
share
Sir,
the
is the answer 45?
Answer is 45 Newton.
Oh, yes.
Sir?
Thank
Sir, how will you explain the net torque about AB due to two different forces AZ and BZ?
This problem, net torque about which one?
Sir, I am talking about if AB and AZ and BZ are not equal, then how will you explain that torque?
We discussed this at length, no? We discussed this, remember, in the doubt solving for 2D equilibrium, slot of finite length. Same, you have to extrapolate that same idea. If AZ and BZ are not equal, then those two forces can be replaced by a force and a couple.
Yes, sir.
That couple, that is the couple that I'm talking about. So this is my solution. Please check. If you have used some other approach, let me know. Otherwise, just check whether your answer is right or not right. I have calculated unit vector along BM, which is vector BM divided by magnitude of BM, where B is 0, M coordinates was known. So NBM comes out to be something like this. RBC, RBD is again FC, FD all in vector format. And then I said summation MBM is equal to 0. So RBC cross FC dot NBM plus RBD dot NBD dot NBM is 0. If I substitute the values that I've generated, I will get CZ is equal to 45 Newton.
Sir,
Yes.
if ring is infinitesimally small, There is no constraint for mx, my, and mz.
Yes, you are right.
Okay.
Sir, is the answer in question number 6 as per the given one? I am getting a slightly different answer.
We'll get there. We'll get there. 6, 5, 6 and 8. I know there are issues. This, please make sure everybody has got it. Let's wait for 5 minutes and then we'll go to question 8.
Sir, once can you show free body diagram?
This is actually not, I am disclaimer, this is not a complete free body diagram because I did not draw the reactions at the 2 brackets.
Sir, could you just draw the forces for, we would get a wholesome idea?
Yes, I can do that. So they are saying upper bracket
Sir, there how actually rotation possible in all 3 directions.
because if it is infinitely small, no, only one constant at a time. That's why I'm saying now all of you please try, if you don't have a ring, ask your mother for a ring and then try to put a pencil in this and try to see if you can rotate or not rotate the pencil along all 3 axes. I think it will be something like this.
Sir. Hello.
Yes.
So
Sir, I
reactions are
wanted to.
perpendicular to rod.
Come again. What are you saying?
So reactions are perpendicular to rod.
Reaction, the CZ.
No, sir. At point A and point B.
It is related to the rod.
Okay, sir.
Sir, if we are able to solve a question without imagining the forces at the hinges, then why to stress on that? Because it is what.
But this problem you can solve, maybe other problem you cannot solve. It's always nice that everything is clear, right? I mean, you are not going to get this exact same problem.
Yes. Oh.
Okay, I'm projecting my solution also.
Sir, can you zoom a little?
Okay. Ram Sundran, what did you not understand? I can maybe try to explain again.
No, that I'm talking about question 6.
Achha. Okay. Question 6 is problematic.
Sir, we did not have to find all these lengths.
Question 9 is okay. Can we go to question 8? Anybody who does not understand question 9, I think let's not get distracted. Otherwise, we'll get confused whether we are talking about 9 or 6 or 8. Let us, 9 is okay. Can I go to 8?
Yes, sir.
Yes, sir.
Yes,
The 9 I couldn't understand.
What did you not understand? Yes, good.
Oh,
So let us.
sir, this was 9. Oh, sorry, sir. Sorry, sir.
9 is okay. We have 10 minutes.
Yes,
Can
sir.
we go
Yes.
to, let's go to question 8. Okay.
Yes, sir.
Yes, sir.
This is question 8. So basically, this is a drill which is joined to some body at D, and at the wheel you have 2 supports. Now, as it tries to rotate, it is having some torque of 450 Newton meter. We want to find out what is the reactions in the wheel. To do that, let us imagine, let us only draw the free body diagram of member starting. Let's try to imagine what is happening in this area, only in this region. Okay.
Sir, which region, sir? I couldn't see your cursor.
I'm drawing it. So only in this region. Okay. This red box you can see.
Yes, sir. Yes.
This region, free body diagram, if you look from the top, it looks something like this. There is a 450 Newton meter torque that you are applying, and due to that torque, there is a reaction F and F at the two ends, which is like a counter couple. We have to find out the value of this counter couple, then look at the free body diagram of the rest of the structure, where there is a F, and at the wheel there are two reactions.
Sir, why there is a couple?
This is counter. So the body is in a state of equilibrium. You are applying a couple. You are going to get something counter to that, so that your body is in a state of equilibrium.
Sir, in reality too, when we switch on the machine, is there a couple?
Yes. Otherwise, your body will not be in equilibrium. If there is no reaction couple, then your entire body will start rotating.
Okay.
So that couple is provided by D.
This couple is provided by the 450 Newton meter drill. That yes, you are right. So you can find the value of F. What is the value of F?
Sir, I had a doubt in the direction of the couple. We assumed it opposite to that because it means Newton's third law is applicable on torque as well.
Yes.
Okay.
Sir, what is the meaning of the third line in the question?
Third line or third sentence?
Third line.
I did not understand the question, sir.
B is free to slide, but not rotate. So this B, this is free to move in this direction, but it can't rotate.
Why do we need that statement here?
It is not needed. You could solve it without that also. You'll always
Yes, sir.
get statements like.
But it is written that, but it is not, C is not free to rotate about the horizontal axis. So will there not be a movement, restrictive movement?
No, but it is not free to.
But excuse me, sir.
Horizontal axis. Since it is not, that's why we have the resulting couple. Is not it?
Sir,
if it was allowed to rotate, there would be no couple. It would rotate.
Sir, basically that due to that 450 Newton meter couple that is acting on due to the movement, I mean rotation of the drill bit, because of that only we are having a counter couple on the, I mean that arm which we have shown by two forces.
Yes.
So that it is in equilibrium.
Correct.
Oh, okay, sir. Yes, I got it.
And
sir, say about the rotation.
Sir,
yes.
Sir, I am not able to understand the direction of F force. Can you please explain?
Yes, I have.
Force is counting the
direction is
creating a couple in the opposite direction to this 450 Newton meter.
But sir, 450 Newton meter couple is acting in clockwise direction, and our force F couple is also
force also is
acting
in
clockwise
clockwise direction. It should be in the opposite direction, sir.
It is out of the plane.
No. I think this is right. Control. Let's do full screen so that I can draw. Control P. So this rotation is like this. My couple rotation is this.
Sir, it is correct.
So your voice is too feeble, please.
So the red direction that I've drawn, that is the direction of the couple. Blue is the couple that is applied. They are opposite to each other.
Sir, according to the diagram, that green sign is in the clockwise direction.
Green sign is what we are applying to the soil, and the soil is applying an opposite torque
yes.
moment to the drill.
Okay.
Sir, the force will be in horizontal direction or vertical?
We are looking at it from the top.
Sir, can you explain the third line of the question?
Arm B is free to slide in the supporting slit. So this can go up and down. So this is allowed. This is allowed, but not allowed horizontal axis. So this rotation is not allowed. So this cannot come here. This rotation is not allowed. Therefore, I'm saying that there is going to be a counter couple to this force. If it was free to rotate, then this counter couple due to F would not be there. The fact that it is not free to rotate, that's why I'm having a counter couple. It cannot rotate like this. Like it could not go like this. It cannot rotate like this. From the top, let us say you took a drone photo, from the drone view, whatever you are getting, it could not rotate in that plane.
Yes, sir, got it.
Sir, what is the direction of force in vertical direction or horizontal direction?
This is in the horizontal direction. F is in the horizontal direction.
Yes, then the net force of the wheel is in vertical direction.
This is the free body diagram of the wheel. So this part I have zoomed here. There is going to be a normal force FA sine 30, FA cos 30.
Sir, the back of the wheel will also have the same normal reaction.
No. When it is, there will only be reactions at one of the tips. So at A, it is going to be at the first half. At B, it is going to have at the second part. Since it is about to rotate, the reactions at A prime will be 0, just like it will be 0 for B. So either it is A and B prime or B and A prime. It cannot have reactions at all four.
A and B prime, sir.
Yes.
Can you please explain why that both of the A and A dash cannot exert reactions again?
Sir, I did not get this point of A and B prime, and why only 2 points the force will have.
This wheel is resting at 2 points, A prime. Okay. And this back wheel is resting at B and B prime. Now, due to the force that we are applying, the wheel is going to lose contact with A prime and B. So there will be no reactions there. It will be only at A and B prime or vice versa. At the same time, because we are applying a torque, there cannot be reactions at both A and A prime. It is going to be one of the two. I am assuming it will be at A and B prime.
If cos 30 degree will tend to move this truck, right? So
FA cos 30 is the normal reaction. FA sin 30 is the horizontal reaction.
No, sir. The F cos 30 degree, which is in perpendicular to A prime line. That force.
Come again. Repeat.
Yes.
Sir,
Sir, why have you applied F force
No,
on the
let me
bottom left?
So you were saying
degree
something about
which is
FA.
perpendicular to A prime. Sir, I am talking about F
Wow.
cos 30
Wow.
degree force, which will be applied on the truck. So, which force will balance that force?
FA cos 30 is balanced by the mass of the truck, which is mg.
Sir, F cos 30. F cos 30.
Say in the rightmost figure.
Yes, sir.
Both these F are parallel to each other and they are cancelling each other. They only cause a couple. It is perpendicular to length BD. This is the top view of BD.
Who is providing that couple?
This couple is the equal and opposite reaction due to the soil.
That you have drawn in blue ink already, right?
So the resultant of that, so there is going to be equal and opposite reaction, which is this couple F. The equal and opposite reaction to this 400 Newton meter is caused by the two Fs that I have drawn.
Sir, the moment that you have drawn in blue color, is that the moment provided by soil?
Yes.
But that is in clockwise direction.
Clockwise is what you are doing to the soil. Reaction to that is
Oh,
counterclockwise.
acha. Okay, I got it.
Sir, where did this F came? 2F forming couple.
Is the counter couple to the 450 Newton meter that we have applied.
Sir, I don't know.
No, sir, I am talking about the red one that you have marked with circled with red one.
That's what. Now the 2F is the counter couple to the 450 Newton meter load that is applied.
Why do we need a counter couple here?
And
because the body is in a state of equilibrium.
And sir, what is this anti-direction 450 Newton? That is also a couple.
That is applied. That is you are getting from the soil. Now if you draw the free body
Sir,
diagram
F at the
power unit.
contact.
This is the free body diagram of the power unit. The free body diagram of the power unit is in a state of equilibrium. Power unit is getting a load of 450 Newton meter from the soil. It has to be in a state of equilibrium. So there is a counter couple which is made by the two forces F.
Sir, I can't understand the reaction at wheels, sir. So A dash and B dash.
That will get there. So is this understood? Is the free body diagram of the power unit. So this is the free body. This one is the free body diagram of the power unit.
Sir, F is the force applied by the body.
F is the reaction that the body is getting counter to the torque. This is the reaction couple.
Sir, I have another doubt that when we show free in the free body diagram a movement from an external source, why don't we show the force that causes it?
We can show. Why not? It depends on problem to problem. Yes, we can show.
Sir, in the rightmost figure that you have drawn about the cart, sir, because I mean the two forces that are causing the counterclockwise.
I'm hearing many voices, so I'm muting everybody. Then you can ask again. Okay.
Okay, sir.
It is echoing again for me. Yeah, please unmute yourself and ask the question.
Yes, sir. I am asking about the rightmost figure about the cart. I mean, the on which the drill is placed. You have drawn the FBD of the cart on the rightmost side, and there is a force F that is acting on it. I mean, I am asking that there are the two forces on the the arm, which are balancing each other. Then why is there an extra force which is acting on the body again?
Equal and opposite. So I'm imagining that this power unit is joined to this unit which has the wheels. And I am drawing the free body diagram of the power unit, and then I'm drawing the free body diagram of the rest of the structure. If there is an F, which is an internal reaction now, equal and opposite F will also have to take place.
Sir, can you please explain why force is not drawn?
Why? Which force?
The external torque, when it is applied, there must be a force that causes it. So why that force is not shown in FBD?
First, we are drawing the free. Okay, let us go step by step. First, draw the free body diagram of this soil. In the soil, a 450 Newton meter torque was applied. Counter to that, you got a 450 Newton meter. Now, let us draw the free body diagram of the drill bit.
No, sir. At that point, we applied 450 Newton meter externally, right? Then what? Why don't we show the force
on the soil?
On the
soil.
Background noises are there.
Yeah, please mute yourself. Those who are not participating, those who are not asking any questions. I think this way is getting hard. Thank you. Yes, please.
The original torque that is applied from the ground onto the power drill.
Originally, the soil is getting a torque of 450 Newton meters. It is having a reaction to that.
Yes.
That reaction we are taking into account.
Okay.
And sir, in response of that reaction, we have applied two forces F.
Yes. This is the counter couple. These two forces F are causing the counter couple to my.
Sir, excuse me, sir.
Sir,
Yes.
if we are applying external
Sir,
torque
from
in clockwise direction, then should not we get our receiving torque in counterclockwise direction?
That's what
Means,
we've done, no?
no, I mean, you applied the torque in counterclockwise direction, the blue ink one.
Hello? Yes.
That is the external torque, no, on the drill.
That is the reaction which the soil is giving.
Okay. Okay, got it.
450
So this is the torque acting on the
drill.
BA.
This 450 Newton meter drawn in blue ink is the torque on the drill bit. And then I'm drawing the free body diagram of the power unit. Power unit is subjected to a reaction torque of 450 Newton meter, and there is going to be a counter couple to that, which is F, which are caused by the two forces F. After that, I'm drawing the free body diagram of the rest of the structure minus the power unit. So there is a force F, which is the internal reaction, so they have to be equal and opposite, and the reactions at the wheel. The wheel part has been zoomed here. That you are going to have normal to this support, you are going to have an FA, which you can have two component, FA sin 30, FA cos 30. Now, I think one common mistake that people make is that now the question is, should there be a reaction at A and A prime both or only one? The answer is, due to this torque, the entire vehicle or car is going to have a tendency to rotate. When it has a tendency to rotate, it is going to lose contact with A prime. So it is going to, in the wheel A, it is going to lose contact with the back part. In the wheel at B, it is going to lose contact with the front part. So the reactions are going to be at these two edges, which are marked in dark blue. The free body diagram of A is this. And then you can solve it. Clear?
But in answer it is given
Hello,
FA
sir.
prime.
Sir, the force with blue ink on the body.
Yes, this one.
Sir, if you take the cos component, how it will be balanced?
There are reactions at the wheels.
Sir, perpendicular to the wheels.
I think it will be balanced by the weight of body.
Yes, it has to be balanced by the weight of the body.
Sir, FA and FB are equal.
F is parallel to ground.
F is
So can you show the solution after this?
Is my solution visible? No, I don't have the, I did not neatly write the solution. I just do the free body diagram.
Sir,
This-
which part will have the normal force, A or A prime?
It, according to the convention that I've used here, it is A.
But
but
the
in the
answer
answer
is
it is
that
given
if A
if it
prime.
has.
No,
Yes,
it
sir.
should be FA is 93.75, FA prime is 0, I think.
How
We'll check it
Right.
is given A or A prime.
A or A prime. Na? It will only be one, it cannot be both.
How did you decide A?
Based on this rotation. It doesn't matter actually. The choice of A or A prime will not matter. The equations of equilibrium will still be the same. Because if it is A prime, then it is going to be B.
So shouldn't the reaction at A opposite direction? Because if we can you say the equilibrium reactions you applied?
Which in this one, what did I do? 1 minute, let me think.
There won't be equilibrium without that weight.
But we'll not write that. Na? Wait, 1 minute. Huh? Let me search.
Sir, the force on both wheels are same or what?
Force in both wheels have to be same. Everything is symmetric.
Yes.
But then it should not be in opposite direction to cancel each other. By symmetry.
So basically, I found it. F into 2.4 is 450. So F is 187.5 Newton. Okay?
Yes, sir.
Sir.
Yes.
So total reactions is F sin 30 is equal to 2FA sin 30. That is the equation that I had to use. F sin 30 is equal to 2 into FA prime sine 30.
So both can how can the reaction at A be in the direction you want you have shown?
It is going to be perpendicular to this wooden block. So FA sine 30 and F sine 30 are parallel to each other.
But the component
That
of
is
F
correct,
will
sir.
be towards the back of the vehicle.
That's why I've done 2 FA into sine 30 is equal to F sine 30.
Sir, F sine 30 from A wheel and B wheel will cancel out each other.
No, they will add up.
Both wheels will not have
FA.
same normal force.
No, there is same normal force.
Yes, normal force will be same on both.
Yes, sir. The B will
Cancel
cancel
out.
out each other.
Yes.
Horizontal component will
you
cancel
have
out, only
shown,
vertical remain.
So the second FBD and the third FBD of the wheel are different in direction.
Sir, the arrows that you have marked near the wheels, that is the direction of force on the block or force on the vehicle?
Force on the vehicle normally should be.
What would happen with
Okay, let me.
F?
But how is it possible?
I will discuss this. I will send you a detailed
A is
solution
wrong.
of problem
But
number 8.
the force that is acting on the, I mean, the square on the right side, I mean, that F force. So that force shouldn't be there in the first place because the force is balanced already by the, I mean, when we are creating the couple, the force is already balanced. So I couldn't understand that why is there a need of another force which is now it is becoming unbalanced because the cost component of the force is not being balanced and the, I mean, the components F A sine 30 and that F B sine 30 are also cancelling each other. So there is no force which balances F sine, I mean the sine component of F that is acting on the square body. So there is no force that is balancing that one.
ठीक है. I
Sir,
understood. Let me get back to you. I will discuss this. Something is missing somewhere. I am not able
Sir,
to.
your answer is correct if you consider that both the backs up means the reaction is at A dash and B. Sir, then means there would be a force from the positive X and 2 forces from the negative X. Then it would be the same.
Okay, let us do something. I will send you a detailed solution including explanation of class question number 8. I will upload it. Let me discuss it with other teachers. I will get back to you. Okay.
Okay, sir. Okay.
Okay.
Yes,
and
Sir, please send this video to.
Huh?
But I just wanted to say that the force exerted by the
Question
blocks
number
will not
6
be
also,
radial.
please, sir.
Yes, sir.
So
Question
the
6
component will
also.
also be there.
Yes, sir. For 6
Too
also
many
a
people are
detailed
talking
solution.
together. Wait. Question number 6, I was coming to that. So question number 6 is somewhat disputed in the sense that depending on how you visualize it and how you solve it, you can get 2 different answers. Okay. I can send you detailed solution for my interpretation of the figure, but I can also tell you that there are some gray areas. I mean, every year we have a very long discussion on that problem in the class where different students have different ideas. I will send you a detailed solution, but you don't need to spend too much time or thinking about it, or don't spend your time on that question. Questions like that, questions which are disputed, will not come in the exam.
Sir,
Okay.
just can you say that the tension in both cases will remain same or different?
It will be symmetric. Just symmetric.
No, I'm not asking tension in both string. I'm asking about tension in both cases.
See, I think it is difficult to visualize which cases. So I will send you a detailed solution. Please have a look. But also I am also giving you a disclaimer that you might have some other idea. There is no right or wrong. And
Sir,
there is
is
some
it that
ambiguity
we
in
are
the question. So there is some ambiguity in the question. I think let me send
Okay,
the
sir.
detailed solution. Please have a look. And also my suggestion is there is not much benefit in spending too much time in this question because ambiguous questions will not come in the exam.
Okay, sir.
So I will send you detailed solutions of question number 6 and 8 by tomorrow. Okay.
Sir,
Okay,
please
Sir, I
send
had
us this
another doubt.
recorded lecture also.
Dhananjay, tell me what is your doubt.
Sir, when we are saying that a moment or a torque is applied on a body